Okay, in this video I want to do an example of what's called synthetic division. And synthetic division is when you basically are dividing one polynomial by a first degree polynomial, so x to the first. It may or may not have, a number in there. If it's just x, you would just break things up individually and it'd be pretty easy anyway. So suppose we want to divide, again, x cubed minus 2x squared plus 3x minus 4. We're going to divide that by x minus 2. What you do in this case is, whatever we're dividing by, so notice there's a minus 2, it's x minus 2. We actually take the opposite sign and we'll use positive 2, and that's what you stick outside. And then notice I have 1x cubed minus 2x squared plus 3x minus 4. Notice there's no terms missing. It starts at the third degree, second degree, first degree, and then we just have a number. All we do is we write the coefficients. So 1, there's a negative 2 in front of the x squared. There's a positive 3 in front of the x. And there's a negative 4 just hanging out. And with synthetic division, what you do is, the first term, you just drop it right down. There's nothing to do. And then the idea is we multiply. So I'm going to take positive 2 times 1 and then stick that number in the next spot. So it says positive 2 times 1 will give us positive 2. And then what we do is we add those numbers together in this column. So negative 2 plus 2 is going to give me 0. And then we repeat this process. Now we take positive 2, multiply it by 0, and that's what we stick in the next column. So it says positive 2 times 0 is just going to give us 0. So if we add those together, we'll get positive 3. And then again, I take positive 2 times positive 3. Let me erase my little red dots here. We'll take positive 2 times positive 3. That'll give me positive 6. We add the columns together, and we get the number 2. This last number is going to be your remainder. Remainder. Let's see if I can spell correctly here. And what it says is, in summary, it says we can actually, so the numbers on the bottom are what are important. Okay, so it says we can actually